Now we have an agricultural question to consider. In this case, a walnut grower estimated from past records if 20 trees are planted per acre, each tree will average 60 pounds of nuts per year. And then there's some additional yield for each additional tree, or I'm sorry, a decrease in the yield for each additional tree. How many trees should be planted to maximize the yield per acre, and what's the maximum yield? So we want to start by establishing our function f of x. And in this case, we can look at, or start off by looking at the yield per tree. So yield subtree, or whatever notation we want to use to recognize that. So the yield per tree is going to be 60 pounds minus 2 pounds for every tree that we exceed beyond that 20 tree minimum. So x is however many additional trees. So if we have 21 trees, x is 1, meaning each individual tree produces 2 fewer pounds of nuts each year. So we can also look at the number of trees. So we know that there's going to be this minimum of 20 trees, and then we're considering adding some number of trees to that. So then we can come up with an expression for the average yield per acre. And we can express that as the yield per individual tree, so 60 minus 2x, times the number of trees. So this is the same idea as price times demand. This is how much an individual tree will yield times however many trees we have. So expanding that out will give us negative 2x squared plus 20x plus 1200. So the next thing to do is establish the domain. So the last few examples we've been always calling back to that original example. Now we have to set up a new domain for this problem since we have a new scenario we're working with. So x is the number of additional trees that we're going to plant beyond beyond 20. So the minimum value that we can have for x would be 0. And then we're not really given any information about any kind of upper bound. So we would probably just say that the largest is infinity. There probably is some restriction on how many trees can be planted in an acre, but nothing in the problem gives us that. So our domain is 0 less than or equal to x less than infinity. So now we can establish the problem. And what we want to do is maximize that average yield per acre. So we want to maximize the function negative 2x squared plus 20x plus 1200 on the interval from 0 less than or equal to x less than or equal to infinity. And let's just give this function a name, f of x, so that when we express its derivative, things like that, we'll just have that notation built in. So the next thing we want to do is, again, find any critical values. So the derivative of our function is going to be negative 4x plus 20. So setting that equal to 0 is going to give us a value of x equals 5. And then again, we'll apply the second derivative test, where our second derivative is negative 4, which is less than 0 for any value of x, which implies that f of 5 is an absolute maximum. So now we can use that information to answer the questions that are being posed. So our original function evaluated at 5. So if we're planting x equals 5 additional trees, plugging that back into our original function is going to give us 1,250. So our interpretation here, the answer to the question, is that a maximum yield of 1,250 trees, or 1,250 pounds, will occur when we plant 5 additional trees.